Hey, I'm Amit Yadav. I have around 6.5 years of experience in IT industry, working as a full stack Java developer, and for the past 4 years, I have been working as a machine learning engineer as well. Coming to the teaching domain, I have been in teaching domain for last 6 years, where I have been teaching part time, and in data science stream, I have been teaching for last 2.5 years as a data science instructor in two of the edtech startups. I've also been giving corporate trainings on AWS and Java. So today in this demo lecture, we will be going through confusion matrix and AUC ROC curve. This is a very important concept which we need to learn for model evaluation of classification problems. Right now, let's get started. So suppose there is a case that we have a binary classification problem. We will start with the most basic. So in case of a binary classification problem, what can be the possibilities? So what can be the actual values? The actual values we'll consider as 0 and 1, right? It can be true and false, it can be yes and no, but for the sake of simplicity, we will consider 0 and 1. So let's consider the actual value can be 0 and it can be 1, right? For 0, what can be the predictions? The prediction can be for 0, it can be either 0 or 1. And when the actual value 1, the prediction can be either 0 or 1, right? So I will mark it this for a consistency, right? Now, suppose this prediction. So I will try to name it something for our understanding. So tell me something. This prediction 0, is it a positive prediction or a negative prediction, right? 0 means negative prediction, so I will simply write negative. This one is positive prediction, I will write positive. This is negative, I will write negative like this, and this is positive, I will write positive like this, right? We are done. Now tell me something. If this prediction was correct, yes, actual is 0 and prediction is 0, so this is correct. So I will write true in front of it. Here it is false, I will write false in front of it. Here it is false again, I will write false in front of it, and here it is true, so I will write true. So how are we going to name it? True negative, false positive, false negative, and true positive. These are the four possible values when we are trying to perform a classification prediction, right? So now these are the four terms how to use it, right? In order to use it across various properties, we will need to basically assign them in a certain way, or like place them in a certain way that it becomes easy for us to memorize, or it becomes easy for us to remember the concept, right? So what we are going to do is we are going to place this actual thing in a square box. So this, we are going to prepare the confusion matrix. So let's just do it a bit fast. Here we will place the actual values, and here we will place the predicted values. Actual values, we will first place 0, then 1. Here we will first place 0, then 1, right? So 0, 0, 0, 0 is true negative. True negative. Then 0, 1. 0, 1 is false positive. Then we have 1, 0. That is actual 1, but prediction is 0. So this one. And we call it false negative. And this one is by default true positive, right? Now, how to use this? We can use this particular table to create various model evaluation parameters, namely precision. Precision is equals to the number of true positive values divided by true positive plus false positive. I'm not going to the entire definition of it considering the time constraint we have. I'm just writing the formulas, okay? So that we will be able to use it in the near future. Then we have something called recall. Recall gives again true positive divided by, for precision it was this, Precision says how many of like predicted correctly out of, see what's happening here is when we are trying to find precision, wait a bit, when we are trying to find precision, we are trying to find all are predicted as one, but how many of them is actually one. So this is precision. Similarly for recall, all the values in my universe is actually one, right? But I want to know how many of them are actually predicted as one. So recall is TP by T, that is true positive by false negative plus true positive, right? This. And then we have something known as F1 score, which acts as the harmonic mean of precision and recall. So it like harmonic mean. So the basic formula goes like this: 2 into precision into recall divided by precision plus recall, right? Now we are done with this. I will teach you two more parameters, that is which we are going to use in AUC ROC curve, right? What is the use of AUC ROC curve? Use of AUC ROC curve is to know the performance of model across various thresholds, right? So we'll get to that. Let us write now TPR. What is TPR? True positive rate. It's very simple. True positive rate means true positive divided by true positive plus false negative, right? So it simply takes this portion of the data. This portion of data, out of this, how many is true positive? And false positive rate takes this portion of data, this portion. Out of this, how many is actually false positive? The false positive rate is false positive divided by false positive plus true negative, right? Now, we are going to use these two in AUC ROC curve. AUC ROC curve, what is this? I will just write AUC ROC curve is nothing but area under curve hyphen. This one is receiver operating receiver operating characteristics curve. What it does, I will tell you. Let us first draw this and then we will get to know what it actually says. Okay. Because we'll first see how it works and then on the go we will learn what is the use of it. So here we will put true positive rate and here we will put false positive rate, right? Now, I will ask you something. Consider you want to predict something, right? And the threshold level, generally what happens whenever something has 50%, more than 50% probability, we predict it as true. For example, I will go to school or not. Leave it. It will rain today or not. If the probability is 51%, generally I predict it as true. If the probability that it will rain today is 30%, I will predict it as false, right? So this is the basic understanding. Now consider that I want something, draw. I want something, what happened, draw. I want something that even if the probability is 0%, I want it to be predicted as true. So here what happens, the threshold becomes 0%, right? Now consider for 0% threshold, for 0% threshold. What will happen for 0% threshold? Actual values does not matter, it is 0 or 1. It will always be predicted 1. So what happens is when we are talking about zero threshold, in prediction, everything will lie under this bucket, one bucket. Understood? Because even if it is 0, my threshold is 0, right? Here, even if the actual value is 0, so what is that? Even if the actual value is 0, say 0 and 1. So probability of 0 will be 100%. Agreed. But probability of 1 is 0%, right? And threshold is 0. So that will be predicted as true only because it crosses the threshold. Understood? Now what happens when we are talking about zero threshold? Let us calculate what will be the TPR and what will be the FPR. As we understood that in case of zero threshold, actual value, whatever be it, 0 or 1, the prediction will only lie in this bucket, right? This will not lie in this bucket. Done. Now we are going to FPR. What is FPR? FPR is false positive by false positive plus true negative. See, false positive, it lies here. False positive lies here. True negative is this. So this is going to be 0. So whatever be the value of false positive here, x by x plus 0, it gives x by x is 1, right? So false positive rate is 1 for 0 threshold, right? So for 0 threshold, FPR equals to 1. Similarly, true positive rate, TP, true positive. This will be, let's say true positive will be x, right? Let's say true positive will be x plus false negative here. So this is going to be 0 for 0 threshold, right? This will not have any value because all the value lies here. So suppose this is x as well. So x plus x0 equals to what? For better understanding, we'll consider it y. So y by y is 1. So for 0 threshold, what's happening? FPR is 1. Let's say this is 1, this is 0, and this is 1. So FPR is 1 and TPR is 1 as well. This, right? Now consider for 100 threshold. For 100 threshold, what will happen? For 100 threshold, what will happen? Consider we have something that today it will rain or not. The probability of raining is 99%. Not raining and raining 1. So not raining is, let's say 1% it will not rain and 99% chances that it will rain. But if we are having 100% threshold, then what will happen? The prediction will go to not rain only. Why? Because here the probability is only 99%, but I want 100% probability for it to be predicted as true. So if it is 100% probability, we can safely assume and say that every prediction will go to 0. So for 100% probability, what is happening? All the predictions, let's take this one. All the predictions will go to this bucket for 100% and all the predictions will go to this one for 0%, right? So for 100%, let us calculate. What is TPR? If you go to TPR, in numerator we have true positive here. It will be 0. Why? Because all the values are in this one. So true positive rate for 100% threshold is 0 because numerator is 0, does not matter what is in the numerator. Similarly, for FPR, false positive is also 0 for 100% threshold. So for 100% threshold, what happens? False positivity is also 0. So where does it intercept? It intercepts as 0, 0. So for 0% threshold, it intercepts at 1, 1, and for 100% threshold, it intercepts at 0, 0. Now, here comes the thing. As we increase the threshold, or say we decrease the threshold from 100 to 0, along each threshold, it will have some some coordinates. So like this, like this, like this, like this, like this, like this, like this. So suppose this is the coordinate. We'll try to form a line, right? Let's say we form this line. So it's like that. Now, I can find through this graph where at which threshold my model is performing best. My model is performing best where TPR is the highest, but FPR is the lowest, right? So if you see here at this point, we are having the highest TPR, but the FPR is lowest. So we can safely say that this threshold, let us consider that this threshold is somewhere 60%. So we can say that this model performs best at 60% threshold, right? So this is how we use AUC ROC curve to determine the threshold. There are much more fractions and equations involved in this, but in interest of time, I'll be stopping the session here only. Thanks a lot. If you have any questions, feel free to reach out. Stop recording.